think next up we have Peter. I did see, I think, oh yes, there you are, Peter. You've moved on the screen. How are you, Peter?
Yeah, good. So like it's early in the morning rather than late at night, so it makes a little bit of difference. And I can have a cuppa or a coffee, and wake up a little bit. So that's good. How are you guys? Good. Go
Yeah.
on.
Yeah.
Do you like the later time? It suits me better, but yeah. So anyway, so
Yeah.
yeah. So yeah. Sorry, Rob. Yeah.
No, yeah, I was just going to say that you were talking about, I think, Tachyon and RISC-V maybe, and you've been doing some interesting things. So we'd like to see that. Thank you, Peter.
All right. Thank you. So, yeah, guys, I've just been ordering all these RISC-V chips from WCH, a Chinese company who's they're famous for, or infamous maybe, it's for that 10-cent RISC-V chip, that little 8-pin chip that's you can't even see, because even if I stuck it up on the end of my fingernail, you wouldn't see it. And I've just lost it. So, but we can throw around RISC-V chips. It's not a problem now. But the thing is that what I want to do is to build a fourth into that chip, so that I can just talk to it and program it up for simple tasks and perhaps even more complicated tasks, and also extend that RISC-V that concept to the larger chips that are available there. I might share my screen here so that we can share screen. I'll share hopefully the correct screen. I've got a few different ones here. All right, I want to make sure that it's got the right one. Desktop 2. Here we go. I think that's the one. Looks good. And okay, you guys can see that now. Okay, screen share there.
Yeah.
Yep.
Good. All right. So over here we've got the. I'll just move my zoom around. Now over here you can see this part here. We've got the CH32V003, and this is available in the tiny little mentions down here. SOP 8 package, the 16-pin package, and of course the TSOP 20 and QFN 20. So I decided to prototype with the 8-pin one, because I want to see what I can do in the smallest type of package, because traditionally I've used little tiny microchip PIC chips in 8-pin package, having to program them in assembler, and it's just awkward. And I hate programming in assembler and those things. And I like to be able to get these chips. They run on 5 volts as well, and just have them pre-programmed with Tachyon 4th, and that way I can either load an application in just by typing in a few lines of code, or I can even use them as a scripting engine. So from another processor, I can send commands through to it and get it to execute immediately, etc. Now, this particular processor here, I've got a little board for it. I'll just show you that one there too. You can see over here, I've got the, hopefully I can bring that up a little bit more. I don't know. There it goes. Doesn't want to go too large. Okay. So I've got a little eval board for that there, and that one there has a little the little TSSO P20 pack on there, and I need a little programming dongle for it, which I happen to have now. I've only just received it last few days, but been a very busy week, so I'm still doing this work here at the moment. But in the meantime, I also have the larger cousin of that one, the 307, I think it is, this chip over here. And as you can see, it even has Ethernet and a PHY built in as well, for direct connection up to the mag jack, etc. So interesting thing about these chips too, the larger ones, are the USB facilities. When we look back here at the block diagram for the 307, we see it has a USB 2.0 high speed and full speed device on there. We can use this for lots of things. They even have much smaller chips that have this built in as well. So what I like to see is RISC-V, Tachyon 4th running on this, and having USB serial. Same concept, by the way, guys, extends to the ESP32 C3, C6 I really don't want to see that one going as well. But I figured I'd start small, start with a small, simple chip. I go back to the 003 and I think, well, 16K flash, 2K RAM. This will take me right back down to the 80s, but we can fit a force in there. And on the P2, Parallax P2 processor, which I developed a board for, and the Tachyon, which is the Tachyon fourth, that was in 12K of that silicon ROM of that chip. And in there also have all the SD card drivers, some FAT32 support, etc. I can fit that in 12K. I can fit it in 12K on a RISC-V, especially with a compressed instruction set. It has, this happens to be, I found out, an RB32C EC, and the E means it doesn't have 32 registers, only has 16. I don't know why that is, but that's okay. We can deal with that. And the C, it handles compressed instructions as well, so 16-bit. Although on the P2 processor, I only ever use, it only has 32-bit type instructions, so I can't see a problem with doing it that way either. And so this should be pretty good working like this. And as you can see, this particular processor, the small one, runs at 48 megahertz. That's fine for simple things that we can use them for. But it also has a lot of peripherals built in, even into the small unit. We have the USART, the I2C, the SPI bus, and lots of other little things in there, little goodies to play with. I think I ended up paying about 25 cents or something like that for the ones that I received. I've just bought them in little 50 lots. Just off AliExpress. And they came through pretty fast, along with all the other evaluation boards that you can see there. And now the fourth itself, I might bring this across here, over here. You can see that on the screen. And essentially it's a fourth where I have the inner address interpreter, interpreting not just addresses, but also certain ranges as tokens. So what happens is, if you can see this all right, I might increase the screen the size of that, drop this back. So you can see in here, this is the main do next loop of the interpreter. We call it an interpreter, don't we, at that level? We're loading unsigned, the high unsigned, loading, I'm trying to remember all these mnemonics here too, but I'm loading 16 bits up here. This is step one. As I mentioned up here, I'll increase that here. And I load up 16 bits up into XX, which is one of the registers I've just named. Point to the next instruction. So we're 2 bytes, so it's one word. And then I just do one extra check before I decide to execute this as assembler. Most of the time, all the primitives are all assembler, so we don't have any code field address. It's this, you just run it as it is. And so it'll say, well, okay, it's an assembler one. If it is less than this particular address, it will simply go up to here and call that assembly code directly. So we jump and link this register, etc., to that, run it. And then when it's finished, it comes back. And so it's a fairly tight loop here, 4 instructions. It's a pity we didn't have any auto increment instructions, but that's all right. And that will execute very, very quickly. Now, all the primitives, of course, are in assembly, but once we want to execute threaded code, well, there's another part there that this is unfinished here at the moment, but another part there that will compare it against a constant that's stored in a register. I'm using registers for a few constants here. It says, just to make it nice and fast. And then it just checks to see that, well, if it's above that, greater than or equal to it, it will treat that as if it's threaded code. So we don't have a code field address that says enter. It just simply says, I'm going to go through a threaded address list. And it goes through to the enter part. There's another part called decode in between these two, which says it's a literal. I can combine, put 10-bit literals in there, negative numbers, etc. If, etc. All the conditionals just in those particular tokens. That works really well in Tachyon. Everything is very compact and it works really well. So I like the concept, and we'll see that happening in RISC-V as well. And that includes the ESP32. And probably what will happen there with the ESP32, very interesting, it's got lots of RAM. And Tachyon really works well when it can run out of RAM and everything is in RAM. It doesn't need to worry about going outside of a 64K page. It can handle it really well there. So I just that's where I'm at the moment. Look, and some guy on the web wrote a flat assembler, and I want a flat assembler. I just want to be able to see every instruction, have it exactly the way I want it to work. And he's written that, and he also wrote a fourth. It's called Des fourth or something like that. I have hardly had a look at it, but I grabbed it very quickly. And he's written one that doesn't really fit in this chip, but that's okay. I'm using it just as a little compilation example. And Des fourth, it's called, this one here. And I've chopped down some of the stacks. He has, I don't know why the data stack's so huge. He had stuff that was really huge, etc., and it's taking up 16K of RAM. So I'm just going to use that as a quick little test for this chip, see if it works, and then use that assembler hopefully to build up the kernel. And because it's quite awkward to define the high-level words in here, because high-level words we see over here, for instance, here we go. Here's where we use okay, this is it. I think that's it. I'm trying to find out where they are. Yeah, but anyway, they use all kinds of offsets and everything else in there, RAM base addresses, etc. And it's rather awkward looking. So I thought, well, I'm just going to get the basics of Tachyon in there and use it to compile itself. So at the high level, keep everything nice and simple, a bit like an E4th in a way, but so we can just extend it as required. So that's basically why I'm at the moment. I did manage to put MeCrisp up onto the 307 since it had an image for the 203, and it seems to work quite fine. I'll bring it across here. Over here, this is talking to MeCrisp on the 307. And there we are. I'll increase that screen size up a little bit here. That helps. Not sure how's it going. Okay, there we go. And reset again. All right, so this particular MeCrisp version is running on the 307, even though it's written for a 203, and it seems to be compatible. The 307 does have floating point though. It has a lot of extras in there as well. And so I've been using this as a little exploratory tool just to check out the peripherals and everything else for that. And I could possibly write my Tachyon on top of this, using this as the way to get it into memory and to test it all out. But I decided I'd go back to that simple assembler approach, try it out on the small chip first, get that going from the ground up. Haven't had time to finish it, as I mentioned, but it's looking good. This particular one is only running at 8 megahertz. I found I wrote some extra words for it and saw that, oh no, it's really just, it hasn't even used anything much in here. It hasn't tried to set up any of the peripherals in such a way. And I think that particular chip runs at 144 megahertz. So it would be quite speedy. And but that'll be later on. I really want to get this Tachyon into 12K of flash on board the chip. And of course, Tachyon compiles each word as it comes in, compiles. It doesn't even have a text input buffer, grabs a word, compiles it. So on a command line, we can hit the enter and it will execute that and release that code space again. So that will be very handy if I happen to have this slaved off a bus, and I'm going to build in that bus software as well, which is a particular version that I use, nice and simple. I can chat to that chip from a master chip anywhere, could be anything, and I can have lots of these little 10-cent micros scattered around. I could talk to that one over there and have it program and up, test it out, and then release it, and the main processor chip can go around using them as little peripherals. So I think it'll be very handy. Haven't done too much, but any questions?
This all runs in pure RAM, right?
Normally Tachyon does run in RAM on the P2 and the propeller chips, but in this one here, it will be running in flash, and then of course there's another area which has the RAM, so very little in RAM. It only has 2K of RAM. I want to maximize that for being able to use most of that for code storage, so that I can just flash it. I test it out, then flash it as required.
Oh, okay.
Yeah, so we can see when with the larger versions, ESP32, 400K RAM, no problem. Everything will run out of RAM, and so that'll be very powerful. Yeah.
So Peter, what is your intention if you want to do applications? So I understand you have an interactive force system, and then you can do definitions. But if power goes away, then you have to reload it.
Okay. Yes. If you just want to, you can run it like that. It's a secure system. Anything you load in then disappears. And that's fine. It'll be from the main processor, but I can flash it in. Of course, I've got, I'll have at least 4K of flash available, maybe even more. And I can say, okay, I want to lock this in. This is a great little application for an 8 or 16 pin or whatever chip, and it works very nicely. Flash that, and I want to make it in such a way that I don't have to flash it beforehand, because it's always a nuisance during development, and just simply have it in RAM, say this is good, back it up, and once it's backed up like that, then it's locked into the chip. But the important thing is I don't need to have all the programming tools. I can just have these pre-programmed.
Yeah, so the chip can flash itself. So you don't need the programmer once you have an interactive force system in it with the flash routines in it.
Yeah, exactly. So I'll just have a little test socket, and I'll probably just do lots of them. And it'd be nice if the factory would pre-program these. Why leave them blank? Put something useful into it. I got that into the P2, didn't I? The P2 chip could have been blank, and they had 2K that they used for through a loader and flash loader, and there was 14K left over. Somebody else wanted 2K to do their SD type boot stuff. I already had SD in there, but I managed to get it in there, and so it's great. It's locked into silicon. You can't just change it easy because it's not just a mask. But if on these little chips here that we see here, especially the little 8-pin chip, and all the little ones like this, if it's preloaded, who knows? Wouldn't that be fantastic? Just order chips, and you don't need a programmer. Just put in your circuit, start talking to it. Really good. And
Mhm.
I mentioned the bus protocol where we can multi-drop them off a single wire or 485. And I've used that in my Tachyon 4th. I've done some demonstrations of that before. Basically, it's a ping pong protocol, implements full duplex over half duplex line. And that means that I can talk to it as if I'm connected directly to the serial console on that particular chip. And yet, at runtime, it can just be used as a local network.
Yeah, well, that puts it ahead of the existing development tools where you have to compile on the PC and then use the programmer to flash the entire chip. And as you say, now we can build networks where you can interactively program parts of the system and update this. And we see how important this is with the Voyager probe and being able to reprogram a system. Yeah, great.
And any other questions? Just still early days, so you can put your little ideas in there too, and maybe I'll implement them.
Peter,
Right.
do you happen to know how much flash was taken when you put ME Crisp onto your 307?
Oh, I didn't check. In fact, I mean, when we look at it here, and I will try to shrink that screen down a little bit, see if that works. Here in X. Okay, that doesn't tell me anything. Of course, the actual flash part of it is in 0. I do have a dump facility. If I have to put anything in here, it's a real painful exercise. My dump. So I should put in the flash. But the thing is, apparently, it takes up a lot of room because it tries to optimize and generate for something that would take 8 bytes of code. I've looked at it, and it will take up 40, 50 bytes of code instead, because it tries to generate machine code for everything. And as we know, the real speed is at the primitive level, not at the high level. So we don't gain anything by having assembler for instead of threaded code.
Thanks.
I think you're familiar with this. For instance, Tachyon, I saw that most of the time it was caught up at the low level, and so I implemented instructions for that, SPI instructions, SD things, etc. And so at the high level, it's still running fast, and then you have all the bit bashing and all the other things, etc. And they're implemented in assembler primitives. And the whole concept was, the idea was that in the past, I'd written fourths that had a lot of assembler in it. I'd look back through the code, and I'd have source code with lots of assembler. I said, no, look, I want to just program in fourth, and to look at what's required to make it run fast. I don't have to code certain things, and so I wrote Tachyon in such a way that I could do that. I could just stick to high level fourth. Very, very rarely will I have a code definition in there, assembler definition in my source code at the application level.
Very good.
So I can't tell you. I think right at the moment what MeCrisp is doing. I could load in my dump utility, etc. in there. If you want, I can just do that right now. In fact, I think I've got it up here. I've got a dump in here, but then I have to slow down. MeCrisp is really, really slow. I've tried a new line delay. Here we go. How about we go? The character delays. We'll see if this works. I'll see if that works. Normally gets lots of errors if I try to go too fast. Yeah. But Tachyon, I can go up to, even on the small chips, I can go up to mega baud rates, and in hundreds, of milliseconds, fully compiled. So over here we can go 0, 100, dump, dump, and there we go. And it didn't like me because not quite sure why it didn't like me just then. But in the RAM area, it's 2000 upwards. I'll dump them as, no, it didn't like that either. 0, 200, dump as longs, dump long. You know what? I don't think I've got this in here properly. I don't think it's compiled correctly. So one of the things I do with Tachyon is have the block load mode, well, not block, but you know, so it has a header in the source code file that says Tachyon, and so it goes into the mode where it will only echo back errors and or little hints, etc. Yep, and report at the end how it went. So that way we can, you know, normally when you paste in source code, you can't follow it. It just goes through there, and you can't see where the errors were. Yeah. That's probably what's happened there, I think, by the look of it, because I can't see down here some of the words are down there that should be working, but obviously it's not. So I'd have to go slow again. I can do that all again and say to it, even slow down. This is really slow. This is terribly slow. It should never happen with this, what happened back in the very early 80s, I think, with Forth, but here we are decades later, and yeah, really, really slow.
Yeah.
Well, one of the tricks, sorry, yes.
Question. Yeah, I saw that. Well, this is MCRISP, but also in Tachyon, I saw that the full names of the words are stored. Do you intend somehow to shorten the names because of the limited memory space, like this was in very early POS systems, only 3 letters plus count? Do you think it's reasonable, or do you just say, well, if the application is too large, then just pick a larger chip?
Okay, so for instance, you know, okay, here's Tachyon on the P2. It's called Tycos. In the ROM, and if I just disable, I'll pull out the SD card, and I'll go. So this is the reloaded version in RAM. It's a full version, so I'll get rid of that, and I will go back up, disable. That way I can just get back into the. All right, so if I reboot, it is now in the ROM part of it. So auto board, I'll put in a special sequence here, go into it, and there it is. This is my original version I wrote back in 2019, and these are the words in here just to show you what's in 12K. As you can see, they're all full words. It sometimes is more trouble to go and shorten them and handle all that. Yeah. It really, the way I've got them in here, they're in a separate dictionary. I think it's called names. Oh, I don't know what it's called now. 200 yes. And there we go. We got a separate dictionary in there, and really, all we need to put in there is the byte for the attribute and the count.
I see.
3 bits for the attributes, and the name, and then 16 bits to point to the code field, etc. So there is an extension to that in the full version where it says, well, if you have one extra attribute, you're going to allow for 20, you know, a 24-bit address or whatever, etc. But that's fairly well. I've never really used that, so that works in there fine. And as you can see, if I pop in the SD card in that one. Even in that one there, I can mount the SD card and do a directory, whatever's in that directory there, etc. And that's just running out of 12K of ROM at the moment. Has lots built into it, even in that particular one, where it was very difficult to test out the Forth and the booting and everything else without actually having real silicon. So but it seems to work quite well as such. So can you imagine that in that little chip? Wow, you know, we can do a lot with it.
I see. Great. Thank you.
I think Travis has a question. Travis?
Yep. Hi, Travis.
I saw that you were setting a character delay. Did you know that there's fourth terminals out there that eliminate the need to set that? For instance, E4com or Zeptocom.js,
Yep.
which are designed to synchronize with fourths in particular. So you don't have to wait for each character to get received properly and all that.
Yeah, that's yeah. I saw you mention that too, and I know that that's used in the past. But really, is that what Well, that's that's better than having the slow terminal that really has to go too slow. But in my Tachyon fourth, I don't have any delays whatsoever, and so I much prefer just being able to use any terminal and hitting it as fast as it'll go. The way that it compiles, the way it handles it word by word, it basically means, and the way it searches the dictionary, for instance, and all that means we don't need any delays in there at all. And so I'd really want to keep the tools very simple. Any terminal. I prefer Minicom on Linux. It works very efficiently, or Terraterm on Windows, and 0 character delays, 0 line delay, and no
I have a
handshaking.
question. When you use the P2, are you using USB or serial?
Okay, P2 doesn't really have USB. It has USB smart pins, but it's it's not. It's really awkward to implement any USB type software on there. Quite complicated. Versus
Okay, I was just asking because I know that with if you're using USB, you don't need a specialized terminal because USB provides what's called back pressure.
the I'm sorry. Can you run that by me again? I missed it.
Oh, I was just asking because you don't need special synchronization if you're using USB. And I don't mean USB where there's a little FTDI on the board, by being actual USB CBC.
Yes, I get you, because that is quite true. If you have, but normally the USB hardware is another layer in itself. Interestingly, the ESP32 C3 and C6 implement USB at the serial and JTAG level. It's pretty much doesn't do any much more than that. So it'll be really interesting to implement Tachyon on the ESP32C series and use USB serial, because it'll be a lot easier to implement since it's in hardware as such. And yes, we don't get that problem. But if you have a look at my screen, for instance, now, and if I reboot with my card back in, so it'll boot back up with the card. And so in this case here, it should come up with a full version. When I want to load something in, I normally just go to, well, here, let's see if we can just show this on the screen here. I'll go to a particular one here, just to show you the speed that we can achieve with this. I think this is one of them here. Okay, this will do. Come across here. So here, what I'll try to do is Visual Studio Code. And in fact, what I might do in here is put in, I'm just looking at something in here that I can put in that I haven't got in there already. There's quite a bit in here already with the multimedia, etc. Multimedia is running at the same time. It's outputting video on a capture screen here, etc. So I could go VGA, and whoops, I did the wrong one, didn't I? Okay, let's get that back again. Okay, here we go. Bring this back again. Here we go. It doesn't look right, does it? Do that again. Okay. Don't worry. I'll leave that there for the moment. But the thing is, what I want to show you is the fact that we can load in code very quickly. So over here, I use the terminal in Visual Studio Code simply course, scripting, in this case, I have a script that is a send script, which uses ASCII transfer to send a file directly to the terminal. Good thing in Linux, because of the way it's piped and so on, we can leave that terminal open. We don't have to close it. We don't have to do anything with it. We can just come along here and say, look, send ILDA. I think this might be one I can put in here. There's one called ILDA in there, which is to do with the laser light show stuff, etc. Okay, so I'll put in ILDA into that one, and hopefully, and that's going off to USB USB 0 over there. Okay, so USB 0, and that's it. It's all compiled. As you can see, that's how it went in there. That wasn't much, but normally even large source code will go in and compile in under a second, fraction of a second, and so we can see the words that are in there now, etc., and the ILDA words that were compiled, which were, I think, I don't know how many words, but in 200 words here, and too much on the screen, isn't it? Okay, so here are the ILDA words up there. So that's just compiled that code there, and that's why I normally do it. It's just I don't have to think twice. I just send it off, and even if I completely wiped everything on here, I do a complete cold start, take it back to the kernel, etc. I can load in all the extensions, nice and easy, extend, and initially, when it first puts it in, it doesn't do the fast mode, but then it switches to it after it puts in some extensions. So I can do it like that, and done. All right, so that's quite a lot of code that went in there, and 1600 lines. And now I can add the assembler, for instance. I can do that, P2 assembler, USB 0. You can imagine this on RISC-V as well. And then I'll load in my FAT32. I call it FAT32 since this is the way I use it in the flat mode, and put that in there as well. Am I happy with it once it's gone in? Yep. Well, there's a lot in there. It's all in RAM. I can type backup, flash, etc. But in this case, I type a Control F because I have a whole heap of controls tied into in here, and there's a backup to flash on Control F. So Control F, flashing, and now when I reset, it will boot out of flash. And so, did I tell it to reset? Do it now. And I'll just reset, and you can see up here in here it's detected the modules I put in there, all the extensions, etc. The assembler and FAT32. None of the extra media modules, but that's how I normally put code in, and it's very quick. So in these tiny little chips, we've got, I don't know, this has only cost like $8 or something rather, or whatever it was from AliExpress, just for this lot of 50 chips. So you can imagine putting chips around. You don't have to, it's a bit like the propeller has 8 chips, really 8 cores. But in this case, you can put those cores where you want them to, and just communicate via a single I/O to all the chips if they're fairly close on the board in the chassis, etc. Yeah, that's the idea there anyway. So and you know, I can see it working really well on RISC-V. As you saw that interpreter part of it, etc. And just being able to implement the primitives, the different tools that I also happen to have a RISC-V assembler written in Tachyon as well. I could use that. There's quite a few different ways I can develop on this chip here. All right. So, yep.
Yeah, you had me thinking, Peter. What's the cheapest fourth on the planet? 10 cents is pretty close, I think. I mean,
Yeah.
there are some. I know there's some
Think so.
Yeah, there's some Cortex M M0 pluses,
Yeah.
but I think they're I think the cheap ones are OTP only. They're not flash parts.
Ooh, wow.
Okay.
Yeah. So
So there are
Yeah.
some ones that, I mean, in volume, you can get down to like 3 cents and stuff, but
yeah,
I don't,
it's,
it's tricky. I like the fact that you can get these things on, 50 pieces for, a few dollars, and it's,
yeah, exactly. And you want a
Yeah.
few hundred. It won't cost much to and the price comes down, of course. It was just easy just to get them like this. And really when you think about it, 5-volt part 2, it's like, well, we have interoperability, we can use them in different designs. Everything's on board, the oscillator, you name it, when we look at it all, everything's on board. We only need power and away we go. Done.
yeah, I think 10 cents would certainly meet the cheapest fourth on the planet.
Probably right then. And when I design a board, I like to spread functions around, like even just on my P2 board, I had a little USB, a little tiny micro, which was originally just a supervisory micro, just a little QFN20. It's a Scilab's 8051 type part. It also ended up implementing USB serial. I've got the serial version, but it's over $1 just for that little chip. And really all I really wanted on there was a chip just to look after some boot functions and power up functions, just to make sure everything reset properly and so on. And this type of chip can do it no problem. In fact, if I just use the 203 or the 200 series with a USB on board, that can do that too. So I like to put chips all around boards just to look after different functions. And propellers made it a lot easier in that I don't need to, but in other designs, it's good just to have an independent function, and that's what it's doing, and will keep on operating, especially in the fail-safe type situation. Excellent. So next time, I hope to have this all up and running. But yeah, see, if I had more time this week, I'd probably have something running. But next time, certainly, yes.
Thank you very much.
We'll call it 10 cent for, shall we?
Very, very interesting.
It's a lot
Yeah.
of sense.
Yeah,
Not too much sense.
Thank you for the heads up. Great.
Hey, Peter, you're,
Yep.
you're around Brisbane or something?
Brisbane,
Is that
yeah,
right?
yeah.
Yeah. I've been working in Singapore for about, I don't know, 10 years or something, and
Yep.
just moved back into Brisbane. I was kind of
Oh, yeah,
surprised to be here in the same city. Yeah.
Oh yeah. Oh yeah. You call by if you like. Yeah. Just message us on Messenger or whatever. There and yep.
Yeah.
Come into the workshop. It's like full of parts. I've got parts.
You got parts out the
I
way.
think
I looked at it.
if you saw, like there's all those drawers down there. There's parts drawers up. If I turn back up here, there's parts drawers up here. And it's like it's I've got parts everywhere, and I've got boards and you name it. So yeah, it's just like I used to do a lot of prototype and production stuff. Now
So you needed stuff.
I can just play, and the trouble is sometimes in the past when I was working on a project, you had lots of focus and you'd want to play. Now I've got I can play, don't have a lot of focus, but now I made myself really focus on this RISC-V, get into it.
Yeah. Oh, it seems like fun. Yeah.
Yeah.
Interesting.
Great.
Very nice.
Hey, I see daylight in Brisbane.
Yeah. I got some light coming up as well.
Yep.
Yeah.
Behind me.
Yeah. That's it. I can hear the birds, etc., and everything else, and you get the kookaburras going and laughing at you.
Yeah, that's true. It's just about that time. Well, 7 o'clock. So it's in the morning. So.
Yep.
That's right. It is too. Yeah. Good.
Yeah.
So if any questions and any feature you'd like to see, and this thing I mentioned about the manufacturer, half jokingly, because they're rather hard to communicate with, but sometimes you can, and so it'll be interesting. You say, there it is, free, no, all works. Why don't you just build it in? Chips, you can use just as well. yeah, I can always put it to them, you know, and that'll be interesting. So you imagine going to AliExpress, ordering 10-cent chips, all built into it.
Yeah, that'd be pretty amazing, convenient, wouldn't it?
Yeah, I'd
Yeah, I
love
think
it.
these things are so cheap. If you drop one, it doesn't really matter, right?
Yeah, well, that's right. I dropped them, you know, just like, well, they're gone, you know, they're gone. And but yeah, it's like the other packages, the small packages they have there, you know, their little. I do like TSSO P20. I do like that, but just for prototyping, because I have my 50mm matrix board in a 50 thou, my matrix board that I use. I thought, well, I can prototype on that very easily, and this stuff here, and you've probably seen it before. One I designed, it's actually very cheap to make, and I had JLC PCB make up a whole heap of these ones, and they've got large holes and smaller holes alternated around, but I can put surface mount parts on there very easily, like that, and
That looks
prototype
interesting.
with that. Yeah, I call that my
Yeah, stick
micro
that-
mat. So it's like I'll try to keep getting this camera all wrong, but yep. So
The camera doesn't pick it up very well.
yeah, that's right. So basically, it's you can see right through it, right? Okay. But
Yeah.
you can see that, and it's got small holes, so I can get the little 50mm type headers I've got here. 50mm headers.
Oh, the kind of half size ones, yeah.
So here we go. Headers. So these are the really fine 50mm ones, and I can put that straight into the board. But then when I put the big headers in, they're not tied or loose or anything like this. None of them are actually tied or loose, so they all go in. You know, I haven't pushed them in properly at the moment, but very, very easy. And I got these boards that are totally plated through, double-sided, of course, and no funny little power tracks which never suit whatever you're doing anyway. But because all the matrix boards seem to have all these things made up for dip packages, etc. I just did one, and
Nice.
also gold flashed, you know, so just get gold on it and makes it very easy to solder up too. And yes, and you know what? Ends up costing me about 30 cents a piece. It's like I'm talking to Jake. If I could just buying a board like that with single-sided copper, nothing else on it, hopeless stuff, it'll cost you $6 just for a bit of board, and it's like, yeah, that's just crazy, you know. This is what they should be selling, but then they probably want $30 for that. It's just like, well, you know.
Oh, yeah, they couldn't sell it for a few cents, could they?
Yeah, that's right. Yeah. So,
Unfortunately.
yes, I've got a whole heap of those.
Nice out there.
Sorry. Yeah. So prototyping wise, you know, surface mount's always a problem, and at times, you know, I will design little modules for certain boards, etc. So
That's the manual for the cart. Are you gonna build it today, or are you gonna? Can't use it unless I build it.
I think Travis is not on mute.
Oh, okay, yeah, that's right.
We talked about having a while having one.
Let's see.
Yeah. So Peter, I noticed. So those chips run at 3V and 5V.
Yep.
That's pretty cool.
Yeah, and that's what attracted me to them. You know, it's 5V operation.
Right.
Nothing else. No clock oscillator. No external memory.
Yeah.
That's it.
But the ADC as well. I mean, if you want to buy, you know, if you run out of ADC channels on your main processor, which happens more often than you think.
Yeah.
You know, something like the RP2040 that's a bit lack on the ADC inputs.
Yeah.
You use that as a controller for the ADC.
Yeah, and in fact, you know, like I very rarely use any I2C dedicated chips such as A to D chips because they're so expensive. It's easy to get a big micro, program it up. I can put it in I2C protocol, or even just serial. In fact, I have some designs which just spit out the A to D just automatically on serial, go through octo isolators and or solid state isolators, and so I can have isolated A to D without having to talk to it. It's just sending me the stream, and I can take the readings.
You don't even set it up or anything. You're not even trying to run like a separate sensor and configure it and all that sort of.
Yeah.
Apart from paying for it.
Yeah, that's right. So you can imagine this little chip being used with the fourth on there, and you type in a couple of lines of fourth, and you say back that up into Flash, and now it is, and you can put it on the other side of an isolation barrier, and it's doing all your A to D sampling and any filtering that you want done on it. But it's done. It's all beautiful. Yeah. So that's the idea. That's how I use the chips.
Nice.
Yeah, and I forgot too. I have plenty of other RISC-V. I had these quite a while back, and these are the Buffalo 808s, but they're triple core, and they have a high performance core, a medium one, and a low power core. RISC-V, way complicated on the documentation. That's why I want to start with something little, and then build up to all these more complicated chips. So, you're wrangling with the data sheet.
And if you look at the like higher up the RISC-V area, there's a lot of to some of those. Yeah, a lot of optimizations and stuff. You just want to not get stuck with them. Yeah, not at the beginning.
Yeah. Well, I think there's going to be as we can see, we've got everything from low end to high end in RISC-V. We don't have that in ESP32. We don't have enough IO. We don't have enough this or that. ESP32 is really nice for what it does. And I do want to use those little chips for even just little micros as well. But thing is, they always need an external clock, and they're 3.3 volt. And, you've got integrated flash, stacked die flash, etc. That's a good thing too. But it's not a simple little circuit, and an 8-pin chip, we can beat that on. But RISC-V, I've had that for the 64-bit ones as well, those modules as well. Lots of different RISC-Vs. I've got the Giga device ones, which seem to be hard to get, etc. Giga device kits. I've got a stack of these ones. Got a stack of different RISC-V, except ESP32, which I'll still have to do.
Yeah.
It'll be fun. This will be fun, just getting this 8-pin chip going, and maybe that's a hackaday thing where I can come along 10-cent fourth.
Yeah. Interesting.
That's right. Yeah, we can do it like that, and just the fact that somebody can plug it in and start talking. You can't do this with Python. They like to put on the RP2040, but it takes up most of the RP2040 resources, and it's not that fast. It's quite slow. Here you're talking about something that's fast. Great, you've got room left over for, and you can use it off bus, etc., and talk to it via terminal. It's like, what's your development system? Nothing. You got a terminal, go for it, plug it in. Yeah. I like the concept.
Yeah, sure.
So sorry I didn't have anything really to show you, but just it's good just to get to this point anyway with having the chips here now and information and just really getting my head around what I might need to adapt.
Yeah, it is inspiring anyways. So yeah, thank you very much.
Thank you.
Christian, now open the mic.
Yes, Peter. I know you had a lot of interest in propellers. And I was asking myself, if we take 8 of those small 25-cent Tachyon programmable chips, could that replace a propeller?
Different thing, but in certain applications, sometimes on the original propeller we used various cogs for serial, just for this or that. For instance, the 307 version of this chip here, just to give you an idea, does come in smaller packages, but it has 8 UARTs on it. So why would I would just use UARTs and all the hardware that's in there. That can do a lot of things. Yeah, already.
It would almost be a scalable propeller.
Yeah,
You want 4, you want 8, you want 16.
yeah, and that's a problem with a propeller chip's very expensive, and you need your power supplies and your clock and everything on there, external memory, and so this makes it a lot easier. Because when I design boards, fine, you can have propellers on your bench top, etc., and all that. I build it into products, a lot of products in the past. I haven't built the P2 into any real product. I intended to, but I haven't ended up using it because it's quite a beast. But I can see that there's a lot of applications where I can use these little chips, the slightly larger versions, and maybe a combination of that and the ESP32, etc. Just and talk to the lot of them in Forth. Yeah.
Okay, thank you, Peter.
All right. Hey, Kristen. All right.
Yeah, really interesting. Thanks. I'm glad I glad I connected.
Yeah, well, it'll be more interesting next time. That's right. That's for sure. And I will have
Oh,
it
yeah,
hooked up,
sure.
yeah, on the bus as well, so we can just talk to them and see them all working. Yeah.
Yeah, perfect.
No, it will for sure be my next experimentation when it's available.
Yeah, that's right. Well, it won't be long. It's I can, I'm almost at the stage where I can put Forth on there and running, and what I did with Tachyon right in the beginning, Christian, it was very simple. I just wrote just enough in the kernel, just to run some primitives, just to run some tests, and I had the thing running up in days, and then I just slowly improved over the few weeks. But most of it was all there within the first few days or weeks, etc. Yeah.
No,
I'm saying
it
it's going to
would be
happen
my
the same
next
way.
experiment because I found Tachyon so easy to use.
Yeah. Oh, that's good. Yeah. Well, I find it easy to use and interesting too. Just talking about Forth just in general. I was using another Forth on the propeller thing, and it was, and I just found it very awkward and very slow to load and awkward. And I didn't have any one particular source where I could just compile that to generate a new kernel. It was created with all these special little helper tools and everything else and so on. And I wrote and it wasn't fast. When I actually put it to use, it was really slow. I thought, what's going on? So I wrote a decompiler, etc. for it. And when I decompiled it, it was like I could see the source properly then, and it was like no wonder it was a mess. And the thing is that when we for production use, I build this in production. I've got to have a really proper Forth, a fast Forth, one that fits in that memory, etc., and is easy to develop on. So. And that was the whole idea. That's why I started Tachyon. Otherwise, I would have been quite happy to use whatever was there already, just to get going. I'm a bit lazy like that, but then once you get going, Yeah. Are you any guys using Forth in commercial products at all?
So I've got I mean, a lot of my products have got big teams and have got lots of engineers writing C++ or C, but what you'll find is that Forth, the production test interfaces are often Forth engines, right? So often the production test guys, I mean, rather than just have a canned production test routine that's always wrong, they want a command line interface. And you can obviously write a command line interface, but the problem is that if they want to do something just a little bit different, Forth gives them, and it's, in terms of number of lines of code, it's not much different between a standard command line parser and a Forth engine, in terms of number of lines of code. And so I'll just put Forth on there, a simple Forth, as a command line parser. And then some of the dev guys use it because they want to be able to poke the hardware to find out why the C code's not running or working. I also had a case a couple of years ago where, and I didn't intend to write a fourth, as is often the case. The mobile app guys wanted to simulate hardware conditions on a underfloor heating controller, and there's a lot of I/O on there, and you need a lot of specialist equipment. And some of the production test guys, some of the mobile app testers were in America, some were in India, and they were like, I need to simulate these conditions. All right, well, for a start, you're going to need a 240 supply, you're going to need all these valves, and I'm like, this is just, they're not actually testing the hardware, right? We've got a separate team that tests the hardware. So I was like, right, okay, what I need is a command engine that was sat on the end of a Bluetooth link. So I just hacked up a simple fourth interpreter and allowed them from the test tool that I'd written before from the PC to connect over Bluetooth and set it in a mode where it'd simulate those hardware faults. So they could test the mobile app, right, on the Android or iOS. And that actually got ported across to another project I was doing, and it got expanded a bit. And, you know, I've ended up as a, I didn't intend to write a full fourth, but that's just the way it happened. And it was the easiest thing to do, you know, so yeah, I mean, this is, and I've also got, as well as sort of shipping products, I also sometimes use it if I've got a test kit, my choice, you know, if it with a Pico, for instance, the Raspberry Pi Pico, you know, hack one of those onto a custom board and you get the board made for a few dollars out of JLPCB or somewhere. Put one on as a piece of test kit to measure some, you know, readings, like a bespoke data logger. And sometimes you can do that in MicroPython, but often you end up, I don't know, fighting against the system. And I needed an RF logger to log and generate RF signals. And I really wanted to put all the code on the PC, right? I don't want to run it on the target device. And what typically has been done in before, a load of the code ends up on the target device, and then you have to firmware update the target device as the spec changes. So instead I run, actually, it's Travis's Zepto4 on a Pico, and there's no hard-coded code at all apart from Zepto4, right? It's an old version of Zepto4 now, and because Travis moves too quick for me to keep up with him. And I just download a bit of fourth stub code, write it into Flash, and it detects whether there's been an update in the host program for the PC, and then it goes, right, there's been an update. You're going to need to wait, you know, another 30 seconds for me to change over the definitions. And effectively, I've been able to pull most of the code over into the PC where it's easy and fast to change. And it just acts as a little stub between the RF chip, the RF transceiver, and the PC. And there's a tiny bit of real-time stuff in there, things like reading the RSSI. But most of the stuff I've been able to avoid, you know, the PC is effectively non-real time, but it just acts as a bridge between the transceiver chip and the, and so there's those sort of things that are, you know, you haven't got time in a project to spend a lot of time writing tools, right? But you still need the tools, right? So I tend to find things like fourth are quite useful for doing stuff there as well.
That's what I call rapid prototyping, but software prototyping.
Yeah,
you can't really do it, you know, by the time, you know, you set up everything, and you have to wrangle the compilers and everything else and so on. But fourth, it's just there, talk to it. And I start from, you know, I have, you know, the top up, top down type concept, but start from the bottom up. When I try some simple routines, yeah, that's good. Change that a little bit, build up, and it is very rapid prototyping. Yeah. But same with the even when I did the little PIC chips, I had to do the high voltage programming thing on it because we use them in production, and we had so many problems with different programming tools and the programming software with gigabytes of it, and it wouldn't run that particular tool, and it was like, well, I give up. And now that I've just written some routines, I just bit bash some commands through. Yep, that works good. That works good. Throw the data in, etc. Check that out. Ramp up the voltage. Do this, do that. It was very rapid prototyping there, and now I've got complete control over programming of that OTP or flash or whatever, the different voltages and testing of it. I can program single location. I can manipulate anything I want now. So much more versatile, and I think that took me a fraction of the time it took for me wrangling with the microchip MP Lab tools. You know, it was such a mess.
Yeah, I'm well aware of MP Lab.
Yeah.
One of many. I mean, you know, we use a whole bunch, lots of different and I use chips at home to do robots and other things, and yeah, wrangling with. I've been writing C for a long time professionally, and I'm like, it's just terrible. And the people who only know C, they don't realize how bad it is. You know, I mean, you know, it's a major achievement when you flash an LED with it when you've got a C project. With a fourth guy, it's just like, well, you just load the fourth on and just toggle the pin. You know. Anyway,
It's, and it's really, really simple. And I show that little one-liner where I just type it in as a one-liner without even creating a definition, and that always amazes guys. You know, it's just like, well, there it is. I just say begin. You know, 5 high, 100 milliseconds, 5 low, 100 milliseconds. You know, again, return back. You know, it's one-liner. Just type that in, and away it goes. Blink, 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 blink. You know. So yeah, that's right. Rapid prototyping, and you know what I like about Forth, it's because say the type of Forth where we have it's threaded 16-bit addresses, etc. It's a one-for-one correspondence as we to the source to the code itself. And so when I look at the source code, I know exactly what it should be doing here and here and here and here. A bit like assembler, whereas versus the compilers or even MeCrisp, because MeCrisp generates all this machine code, etc., and so on. There's no one-to-one correspondence, and here I can generate code. I can debug it very easily. I know exactly what it's going to do. I can even patch it as well. I can't patch any of that other code. So that's part of the prototype. Out in the field, sometimes that's what you need to do. You know, you're just out there, and I can patch that. Yeah. Yeah, all the tools, the MP Lab tools are huge. I had one for the Scilab's 8-bit chip, and of course they try to include everything else, and they called it Simplicity Studio. What's anything but simplicity? And the real simplicity is Forth. Forth is, you know, and I don't know what the problem is. As soon as you mention Forth to somebody, they go stacks, reverse polish notation. I don't even think stacks or reverse polish. I just think, you know, as I said, you know, 5 high, 100 milliseconds. You know, it's what's wrong with that? It's and you know, anyway, but that's all right. I don't know why people have trouble with the concept. They're so taught. Here it is, algebraic notation, etc. You know, we don't speak like that. I always say I go to the shop, we buy 6 apples and 4 bananas. You know, we don't go, you know, buy dot bananas brackets, you know, 4, etc. You know, so yeah, to me it's more natural, and you know, it's a bit like driving stick shift manual. You know, to me it's automatic, very easy. For other people, they can't get their head around it. They have to have an automatic. Yeah. Different folks. But we have fun. That's right. You know, I never have fun with compilers. Never, ever. It's just a headache. A bit like filling out forms.
yeah, I think that it's always. I mean, effectively, sort of algo-derived languages have done sort of a lot of people a disservice, because that's what they think code should look like. And the problem is, I mean, I guess people who do Lisp or Pascal and also complain about this is in the fact that people who only know one thing, they haven't got a concept of how it can be different. You know, you talked about, you know, field patching of units. We've got, you know, millions of devices, and if you have a problem, it's it's really hard when you've got a monolithic C compile binary to do anything. And I know Peter Forth posted something about the patching of satellites, but it applies everywhere, right? And you've got a problem that you can't necessarily debug them. I mean, sometimes on Linux systems you can SSH, but there's a whole complexity, a massive complexity burden there, and you can't go very far into the system. Especially when you've got multiple pieces of components. Often you've got, it's not just one chip that's running everything. I mean, I'm as a software engineer, I want to centralize everything, so I've got control of it. And having multiple distributed systems can cause problems or extend development times. But conversely, you've never got that situation, and you can't get access to these edge and far edge devices in a system often without something like Forth. And there really isn't a simple solution. I mean, there's things like the WebAssembly guys were looking at, and I know there's been some development work on WebAssembly for embedded targets, but it's a really clever technology with an abstract machine, a virtual machine. But it's like I've seen this before. It's like there are simpler ways of doing what you're trying to do, and Forth is one of those.
Yeah. I sometimes think too that talking about WebAssembly, it just takes me back to the days of when Oracle introduced Java. Oracle took over Sun, Mitch Bradley developed Open Boot, etc. Here it was, and this is really great concept. Forth there and debug the hardware, but then use it for Open Boot, and then it's almost as if decided that they'd take that concept and they ended up with Java, and so and we can see all these other concepts, and they have to keep on molding it into their into their traditional view, which is not really all that well, put it this way, even if they did, they could still have the assembly language, okay, rather than trying to do something else, and that way you can still work at that level, communicate with it, see what it's doing, and everything else, and work at a high level if you like. But trouble I had with Parallax with Propeller, they really just don't even like the word Forth. It's just like, come on, we love our C or whatever it is, etc. Spin in the case of chip, but it's really difficult. But as I said, I like it because if we're back here on Tachyon, for instance, if I type in that little flasher loop, for instance, let's make it an actual word here, flasher, and you begin and you say 5 high and 100 milliseconds and 5 low, 100 milliseconds, and let's wait till we hit a key and all that sort of stuff. But when I see that, I've got a one correspondence to it. I've got, there it is, 16 bits, that's a 5, high, etc. I can come in and just patch these things too. So sometimes when I don't even have the source code, I can just decompile that, whatever, make a quick little patch to it, and away I go. If I do that in MeCrisp, it's like, wow, lots and lots of assembly. And what does it do? It says it generates all that assembly, and all it has to do is just wait anyway. So it doesn't need to be, as fast as assembly. Wow. So what are we doing now with the program? Is we still?
I think I mean it's effectively we've run off the end of the program, and we're now in sort of, if anybody's got anything they want to show, so if there's any problems anybody's got, or anybody's anything they want to show, then this is sort of the tail end of the meeting, past the agenda.
We're just rambling now.
Probably think of a better word than rambling, but yeah.
Oh, we're having fun rambling. Don't worry about that.
Peter, could you post, you see the links you've got for these micros in the web links? Could you post that somewhere, either here or on Facebook?
Oh yeah, you know, we've got that. You know, for instance, there's that one there for that particular micro, and so if we go to that one there, and then we'll go. We've got where we got the chat stuff. Okay, I'll pop it all through on what's the best place to post it all? On the chat or?
Well, it's probably you could do it in. You could probably put it in Facebook. I mean, there's
Yeah.
a reduced group here. I think it's sort of this sort of stuff. I did see a post about a week ago, I think,
Yeah.
but I didn't really click that these parts were so cheap.
Yeah.
You know,
That's
especially the
good,
sort
yeah.
of low end ones. So I think it's really cool. And seeing I can
Yeah.
get 50 of the things for almost no money at all.
Yeah,
I'm-
that's
I'm-
right. Yeah,
I seem
I've
to
never used that. Oh, sorry.
no, carry on.
Yeah. Oh, I've never really, used AliExpress before because it was like, so, I thought it was going to be a mess, but I gave it a go and I ended up ordering all this stuff, etc. And you just have to, I double ordered some things because you just have to be careful when how you order it and what you click on and everything else. Because they always try to, get you like that. But yeah, it came through pretty quickly and everything. I'm quite happy with it.
Generally pretty good.
Yeah.
Actually,
yeah.
I actually worked with when I was in Singapore, most of the time, I was working for an e-commerce startup, and we ended up getting bought by AliExpress. Well, actually by Alibaba, the parent company.
Oh yeah.
But yeah, if you fall into their line, and the amount of optimization they got in their supply chain is just unbelievable. If you fall off to one side, you get lost. Your package disappears or whatever. But they usually cover that. That's all right. But I've had heaps of stuff come through, and it's generally been okay, except that they run a marketplace, so it depends on the seller. If the seller's a bit dodgy, eventually AliExpress will notice it and they'll jump on them.
Yeah.
But you might be one of the ones that get a problem. But these guys, these are genuine dealers and whatever that are just using AliExpress to get stuff out of the country. It's not their problem.
Yeah. And it's just amazing. It's just normally over $15 here Australian, whatever. It's just free shipping and depending on what it is.
Yeah.
Yep.
Yeah.
And because I was using Amazon's sort of like, I can order it, like on a Saturday, get it on Sunday. It's good like that. But check your prices because they can be quite expensive. But AliExpress has, especially for electronics, for components level stuff, much better.
Yeah, it's pretty cheap. Yeah, it's pretty cheap. I remember when it was a few years ago now, but they do this 11/11 promo, like the 11th of November promo thing. And on one occasion, AliExpress hired for a week, I think it was 20 or 30, can't remember. No, it's more than 30 flights from Etihad. They hired a whole lot of stuff for what do you call those things? Big cargo planes, the biggest that Etihad had. And they just said, right, we're going to have 40 of those and we're going to run them for a week. And that's going to get everything from China to the US and to here and various other places. We didn't get them in Singapore, we were too small. So we heard about it. And it's like, when they decide to do something well, they also screw things up. But nobody does that.
That's true.
But,
That's true.
yeah, kind of interesting. Kind of interesting.
Yeah. Yeah, quite impressed too. Yeah. So I put the app on my phone, and now I just do a lot of shopping on that one as well.
I mean, they're a bit annoying because they keep shoving ads at you and all that sort of stuff, and trying to get you to stuff that's unrelated and all that. You just have to ignore all that crap.
Yeah. Well, as I said, like even when it says, like here it is, it's $1, and you think it can't be $1, like the LCDs, but then you got to select the right particular one, etc. Make sure you got the right quantity and the right one. It's okay. Once you know that the way it operates, it's fine.
Yeah, it just takes a little while to get used to. Yeah. You end up with the wrong model, or you end up with one or whatever. Or you
Yeah.
find occasionally it's a good price, but then the shipping, like some of them have got cheap shipping and some of them have got the shipping is like 4 times the price of the thing. So you gotta read both numbers, yeah.
Exactly, and you look at that, add it up, and you go, but you know, then they say, okay, you go over this amount, you get free shipping. Okay, well, it makes sense to do the free shipping one, or find it elsewhere, and you know the price of it, and but yeah, you never really spend a lot on any one order. You know, I think $60, $100 or whatever. You know, and you're not going to do that too many times if it comes through wrong. You know, so yeah, it works out quite nicely. So I had all this stuff, all these LCDs, all these things, all these RISC chips. I've got a couple of those big 307 eval boards, which I don't really need. I've got, you know, but anyway, I've got. I'm not worried about that. I've got a few hundred of these little CH32 003s, etc., and 16 pin and different things. That's okay. They're cheap enough, you know. I'll drop some on the floor. They stay there.
Yeah, I noticed Ali and eBay have got for the 003, they've got a small dev board.
Yeah.
22 pin dev board, by the look of it.
Yeah. So there's and if it's got the link, trouble is with the 00. Well, that's right. They need their special link device, and you know, the larger board I've got there, that one for the 307. I've got that particular one there. I've got the dev board for that, and that's got the built-in link into it, so you can just program into USB, and that's how I loaded up the crisp into it. And so the CH32B 307 eval board, eval up here, and so that's the one there, and that's one of the ones. That's not the particular one I've got there, but there's a price there for one. That's more of a module to build into things. I think it's a bit pricey, that one. And but yeah, that's right. Yeah, you can just get all the different ones. So it's got that other one I saw before had the link built into it, which is, where is it now? That one there, dev board. There it is. Some prices, yeah, $20.
Can you patch that? Can you patch? So if you've got the link thing in it, can you patch that across to something else and just use the same link, or you just buy a separate link stick?
Oh, for the programming stick, you're saying, or
yeah, whatever they call it.
Yeah, you can, because like I've got it here. So here's one here with it in a little case, etc.
Oh yeah.
And really, that's just. But you can use it for serial as well, you know. So it does all that.
Oh, okay.
But
yeah,
because it's basically the chip. So they have pins on the other side for RxTX, but then you've got your link stuff. And this particular 0003 chip, or whatever it is, doesn't use a clock and data. It's just as a single IO one, so it's different, you know, because it's has less pins on it, etc. But it does all that.
It hasn't. It's sort of cut down because otherwise you wouldn't have any IO left.
Yeah. So they have their own particular protocol for it. I want to work that one out too, because I want to be able to even, you know, reprogram the chips directly.
Oh, you want to talk it directly?
I want to,
if you can get if you can figure out the protocol.
Yeah, exactly.
Hopefully you don't have to read Chinese to do it.
Yeah. Well, somebody started to have a look at it, etc. And that's good enough, because in Forth, I know that once I've got Forth and I've got the product, it's right. You know, you can make things happen very quickly. Yeah. So that should be good. Yeah. So yeah, different boards around. What are these different boards here? You know? So that particular board I've got there has got the link part on it.
You've got this one. Oh, okay, it's attached. So it looks like it's attachable. So you can do it either way as one unit, or you can split it and use it with something else.
Yeah, exactly.
Oh,
and
okay.
it doesn't.
So that's 307.
Yeah.
Right. Yep.
That's right. The 307. I think actually I did have a web shot. Yeah, web shot of the one I've got. Yeah, there it is, just there.
Same thing. Yeah,
etc. Don't need those RISC chips there, but yeah. So, so the Ethernet sockets, the PHY on chip is only a 10 megabit, but it just does have a PHY, so you can get by like that. You can put on a high speed PHY, and then of course USB, etc. So you can use the
a couple of layers and at the other end, on the right hand side, that's your ambiguous vertical, but you've got two on the left as well. Jeez.
Yeah, that's it. And you can imagine so that on that particular version there for that that board, where are we? The 307, it has the high speed and full speed device, and so it could be quite useful to have that in a smaller version of that chip. Perhaps I think it's called the back in here somewhere. I've got it somewhere. It's not going at the moment because I've got the Zoom stuff in the way. I'll get the Zoom out of the way. And okay, so here we go. The in the different packages, etc. I think we've got whatever they've got in there, but it's a 200 series. So one of these 200 series, whatever they are, they'll have 144 megahertz, and they'll have everything on board. I don't know. Here we go. Got a host device there. That's one particular version, but yes, you get them in really small packages, QFN20. That's nice and small. So yeah, so you can build all those link devices, and if I have my fourth on it, yeah, you could reprogram the whole thing in for UARTs. Yeah. Well, I don't know how much they are, but they're not too expensive, I guess. I imagine that if I went to AliExpress and asked them about CH32V203s, for instance,
they're still pretty cheap.
Yeah. So AliExpress, 20-piece lot of these ones here, which in the larger package, etc., and so on. Yeah, you get to choose your package size. Yeah. So that's a 20-piece, and I'm sure that I can get smaller packages, etc. There we go. Smaller packages.
That's
there.
$25 at like 20 of them.
For 20. Yeah, that's right. So about $1 a piece, and that's because you're buying a very small quantity. When we buy in larger quantities, you just see that price just drop straight down.
Oh, it drops down. Yeah,
a lot. Yeah.
But even the initial price to play with them is not. You're not worried about it, right?
Yeah, that's right. That price, what you're getting, 32-bit chip with all that on board. It's, I think that's a particular one. Did we look at that spec on it there before? But what is
that the one you had? Oh, is that the different one?
The 200 is a slightly smaller version to the 307.
To the 300, yeah. No, I meant the board you had.
Oh yeah, so the board I've got's got the 307 on it, which is the
307.
Two USB devices and a lot of other stuff. And so they're all, you can imagine, you can pretty much choose your 10-cent chip or your 50-cent chip or your $1 chip with everything on it, and
just use which you need, and then you can afford to ignore the rest while you're developing. Just use the bits you need.
Yeah, you don't use all that stuff, and like the ESP32s would be really great if they had lots of I/O on it. They had a chip like that with stacked die flash on there, as they do, and 400K of RAM. Yeah, I'd be using that all the time. Yeah, but certainly I can use the ESP32 for the small things too. Except they're more like they need an external clock, and that's why I like these ones. And internal, everything's internal, and you can run them on 5 volts. Very good.
Oh, okay.
Yeah.
They got the voltage too, flexibility.
Yeah. So be very good, and just even when you look at that, you even have some DMA on there as well, which can be pretty handy as well. 2K.
One channel.
But compared to the 8050 8-bit type chips, which only come along with PIC chips, you're lucky to have 200 bytes of RAM on some of those chips. So this is doing well. Yeah. Excellent. Yeah.
So Peter, Peter, I'm sure
Yeah.
this is kind of an old question, but how do you handle soldering that? I know I like the prototype board that you had, but do you do oven or do you do like the the magnifying glass version?
Okay, both. I love even just manually syringing solder paste onto a board, popping parts
Yeah.
onto it. The oven. I have a 4-minute timer. I have it on, $30 oven. Bang, put it on. 4 minutes, comes out beautiful. But when you're prototyping, yes, you know what I use? I use USB be a Pine one, a Pine Store one, but they're like a TS101 or whatever they are.
So you have a steady hand.
Oh well, look. Once trick is always to put a tin of pad, put the chip down, and tack that on. Don't worry about how good the soldering is. It's tacked down in place. Tack down the other corner, and come along and with your fine solder. And in this case, I'm using a tip on here that's got if you can see it, it's a bit of a flat tip. It's really good.
Yeah.
I can do all
Like a
in
knife
one
tip?
go.
Okay.
Yep.
So do you do the wave?
Well,
do you do the wave version and then you use the solder wick to pull off the extra?
Well, that's what I used to use back in like decades ago when I would do that. But now with this is fine, very fine, temperature controlled. It has a little 32-bit chip in there anyway. Just for controlling temperature and everything. But the thing is that when I do it, I might even post a couple of little videos just showing how simple it actually is, and that when you come up, flux is gel flux. It really makes a lot of difference. If you touch it up with a bit of flux, when you come along with the solder, or you like to say solder, but way it goes, just flows. And especially on this sort of matrix board, with the gold and everything else and so on, it just yes, thank you very much. Yep. And
now, was that board something you designed or did you buy that from somebody?
Oh yeah, no. I gave up getting decent board anywhere, and it has nothing in 50 mil, and 0.05 inch, and so I thought, well, I'm just going to design that, and
nice.
I did in KiCad, and like I said, it's big hole, little hole, and the way it's done, it just makes it really easy to put on SOT 23s or any small SOICs and different parts, and also too with my P2 at the time, I designed it there. Well, this is one of the original versions with 100 mil headers on it, but there's another I can't hold it up, 100 mil headers on it, and, but there's an inside line of pads which are 50 mil headers, and so you can break that off. But so the later versions basically didn't worry about the 100 mil headers on there, just had the very narrow version. I've got some here. In fact, I'll dig one out just to show you. Let's see what here we go. So here's a board. 100 mil on it. It's got 50. I can do a surface mount solder with these ones here, if you can see it clear enough.
Yeah, you got the bracketed.
Maybe underneath. Yeah, okay. But in fact, actually, this will be easy. I'll put it back on the share screen with. I'll come back and I'll put it on the camera there again, and I think you can probably see that a bit better. Yep. Okay.
Oh yeah.
So there it is. So that's really fine stuff. And then you've got this board here that goes onto. And I can just solder it straight onto there, or I can use the little 50.
So you've got
and the board as you
So it's just an alternating large and fine.
Wow.
Right. Yeah. Okay. Yeah. Now I can see it. Now I couldn't see it before, but I can see it. You can just about see through the thing.
Yeah. Exactly. Yeah. And I wasn't sure whether they're going to start charging me a whole heap extra for drilling all those holes, and especially on that. But they just, I got a whole stack of them back, and it was like so cheap to get them done. It was like, wow.
That's pretty cool.
And that's just like a thin, it's just a regular thin FR hole or something.
Yeah, that's right. I've probably got the, I've probably got the KiCad stuff up here too. I'll see if I can just bring it back up on the screen here. So I'll just get it up on this one here first. Let's see, a recent one, Micromat. Micromat. Right, come on, fellas. Where's my Micromat?
Neat little design. That's,
up here.
why hasn't somebody done it?
Well, yeah, this is always the thing, isn't it? It's just like, here we go, Micromat project. Let's go get this one up, Micromat, and see what comes up here. Bring up the PCB, one of the PCBs here. Okay, so hopefully that's it. So I'll bring that across to this other screen now. Okay, you can see that?
Yeah.
Yeah, so
Wow.
that's the idea there. And rounded up some of the corners here, as you can see, for clearances, and it's just beautiful. So you get 100 mil up across here, 100 mil across there, and then you put your SOIC pack straight down on there and just touch it with a bit of solder, and away it goes. You know. So
Wow.
and so when I put the 100 mil in, the holes are big enough that they fit in there. And of course the 50 mil ones, if I put in a 50 mil, 0.05 inch,
Fits right in between.
every alternate one is a big hole, but that's okay. You still solder it, and it's still mechanically strong. Yeah.
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 So
That's a
yeah, I had to
nifty
go and develop that
thing.
myself because nothing around, and there it is, Micromat done whenever I did that one. But yeah.
Oh, part number.
Yeah.
Hmm.
Oh, well,
Nice.
that's the size of 3.75 by 2 or whatever it is, inches,
Oh, okay.
etc. And
Okay.
the 100 and mil and 50 mil parts on it, etc. And that was done back in whenever I did it. Yes, I can't remember, but yeah, back in 2019 when I was prototyping with all this stuff here. So I have board, so I just put that straight on, and yeah, really nice ones, and prototype with it. So that's why I've got these chips, these RISC-V chips in those SIC packs. I can't find the
Yeah,
other
it
ones.
makes it
They're that cheap. I threw them down somewhere and I can't find them now. So
makes it accessible for those tiny chips with the layouts.
yeah.
Nice.
So yeah, I can post up the link to my files there, and anybody can just go and get those done.
That would be nice. Yeah.
Yep.
Cool.
Yeah.
And then, are you doing any more work with the bus communication? That's something that really fascinates me, is to be able to integrate multiple architect, like a RISC-V with a P2 with a, RPi Pico or whatever. I really like the idea of the communication, but I can't seem to wrap my head around how to get the protocol working, because I have some 485 chips, and I was working with the P1 development board, but it's like I can get receive working, but the transmit doesn't work for some reason. So I'm missing something there.
Yeah. Well, because 485 I sort of have in a lot of products, and you have on the Propeller, I've been able to implement a lot of channels of 485. I just use 2 IO, one for the RxTX, and then another one just to the transmit, receive on the 485 chip. And so it's very basic. What you need to do is send something serial, you're in transmit mode, etc., and receive mode. And of course, in industry you have a lot of simple protocols, and Modbus, etc. And bus, etc. Different things.
Is there such a thing as collision detection in any of the stuff that you've worked with, or is it all timing?
Well, there is a mode I have